Hi, everyone, and welcome to class 4 for Python for lab work. So today we're going to be looking at a fundamental thing about Python programming, and it's Python loops. Loops are an inbuilt function of Python, so you don't need to import or download anything this time. Uh, Loops are a key part of creating programs in Python, and there's a lot of information in it actually here. You can see here. A lot of information about it, and a lot of this is going to be repeated in my lesson today. So, for example, what a loop does is basically it repeats the same code over and over again for a piece of data or until a certain criteria is met. For example, print each fruit in the fruit list. It goes through each item in a list and prints it out. You see here. Here's our fruit list. You can tell with the list because it has the brackets on each side. And then we have apples, banana, cherry, and we're going to assign it as fruits. Then we're going to, once we're going to run that, and then we're going to run this for loop. And what the for loop does is that it's for x in fruits. So x is each one of these individual objects in the fruit list. So it's going to, I'll just show you really quick and then explain a bit more. Oop. Why is it doing that? Sorry. Oh, it's like playing the whole thing, not just this. That's why. There you go. So you can see here it has printed out apple, banana, cherry. So it's going through this list one at a time and doing the thing it's supposed to do, the program is supposed to do. So it's just printing out everything one at a time. So the X in this situation is apple, banana, and cherry inside the fruit list, and then it's printing it out because that's the only thing that's coded in. The loops also can go through letters because a string is essentially a list of a different type. So let's just run this, and you can see here it just runs every single letter in banana. B-A-N-A-N-A, banana. So it's treating this string as a list, and then you can run data. You can run each one of them individually, every single letter through the code, which is just here is this print. With the break statement, we can stop and loop before it has looped through all the items. This is not recommended. Every single person that I talk to has actually had a lot of experience of Python. I mean, like decades of experience. They say they don't like break because it can cause unexpected events. It's better to kind of code around it. So I'm going to show you how to do it, but it's not recommended by professionals. So we're going to do the loop again for fruit. So for x in fruit, so once again, it's going to be running all these values, apple, banana, cherry, through it. But instead of just printing it, once it gets to, if the if statement is like testing, if x, so if one of the fruits in the fruit list equals the Boolean function banana, it will break. It will stop this whole thing. So let's run that. And you can see apple goes through the list, gets printed. Apple is not banana, so it just keeps on going. It goes to banana, banana gets printed, and here's a key thing: is that it does the loop does things in order. So at first gets the here, prints banana, and then gets the if statement, and tests if x is equal to banana, and then it breaks, stopping this whole chunk of code. So we don't reach cherry. Keep that in mind. The break doesn't stop it. Will only stop when you actually reach it, not like immediately. With a continue statement, we can stop a current iteration of the loop and continue with the next. This is also not the most recommended. It's not as hated as the break statement, but it is still like something you should try to avoid. Once again, we're going to do the go through the fruit loop, and for the for statement. So it's going to take every single one of these. It's going to run it through here. If one of the values is equal to banana, it's going to continue, which means it's going to loop back up. But if it's not banana, it's going to continue on and then print. Let's run that. You can see here, it first one on the list, apple, goes through the system. Apple is not equal to banana, so it does not trigger this if statement. Goes down here and gets printed. Then it hits banana. Banana does equal banana, so it hits this continue statement. That means it jumps back up here. Banana never reaches this print statement, so it's not printed, as you can see. And then cherry goes through. Cherry does not equal banana, so it continues past this if statement and hits and gets to the print, and it gets printed out, as you can see here. To loop through a set of code a specific number of times, we can use the range function. The range function returns a sequence of numbers starting from 0 by default and increments by 1 by default. It ends with a specific number. So the range function is basically, it starts 0 and then it counts up to whatever number is here. So I'm just going to run this code so we can look at it. So once again, Python has a 0 index. So it starts at 0, so it goes 0. It goes through this. The first number that has x is 0, prints out 0, then 1, then 2, 3, then 4, then 5. So this is a key thing, is that it doesn't actually reach 6, it just reaches the number before 6, so that is 5. So keep that in mind. It doesn't, when you put a range, it doesn't actually reach that number, it just reaches the number right before it. And it's the same. It's just, and this is just essentially think of this as like a number list generator. The range is a number list generator. All right. Now the range function is default to 0 as a starting value. However, it is possible to specify the starting value by adding a parameter. So, for example, range to 6, which means values from 2 to 6, but not including 6. So doing this again, but instead of just putting one number in here, we're actually putting a starter number and an ending number. Run this. And you can see here, it starts at 2, like it has in the code, creating, and then ends at 5, because it's not going to reach 6, it's going to reach the number right before 6. And once again, this is creating a list, essentially creating a list of numbers in like whole numbers. The range function defaults to an increment that are sequenced by 1. However, it is possible to specify the increments value by adding a third parameter. Range to 330. So basically, it's so in Python, and I think also in R, it's start, stop, step. So the first number is the number it starts with. The second number is the number it ends with. And then step is like how big a steps it takes. It goes, for example, I'm just going to run this. You can see here, starts at 2, and then it takes a step of 3 to reach 5, and then 5 to 8, once again a 3 gap, and then 8 to 11, a 3 gap, and it keeps on going until it reaches 29. which is the number right before 30. So that's one way to make like a list of numbers that that have like certain distance between them, and a number of values between them, certain gaps, a certain gap. For loops cannot be empty, but if you for some reason have a for loop with no content, put in the pass statement to avoid getting an error. So basically it's the pass statement can be used for a lot of things, for if statements, and whilst a lot of things is like if basically a pass statement. I'm trying to think of a better way to say this, is that when it gets to this certain part of code, it doesn't actually run, it just goes past it. It just continues on. And it's a good way to stop things from not working. It is what it is. It just makes code pass on, like continue on. We'll continue with a loop until a condition is met or a break statement is made. So the while loop continues on and on until a condition is met, is not longer true. So essentially, so we have x is 0 initially, and the while statement is while x is less than 10, continue. So functionally, this statement right here is a true statement. So x is less than 10, so this is true, so it will run. And let's just run it. And you can see here, it runs x by itself through here, and it prints x, and once x is 0 right now, then it gets to this part where x is actually 1 is actually added to x, which is what this function is. Plus equals 1. It's just adding one number to it, and you can like change it to like be 2, and it still does the same thing. Let's not go like that. Say 2, 4, 8, 6. Let's change it back to 1. Run this again. What you can see is that first time it goes through, x is 0, 0 is less than 10, so this is true, so it continues, and 0 gets printed out. They continue for 1, 2, 3, 4, 5, 6, 7, 8, and then it reaches 9. It's 9. 9 is still less than 10, so it prints out 9. Then it reaches here. That 9 is added to 1, making it 10. It goes back up to the top. Now this x is equal to 10. 10 is not less than 10, so this statement is now false, and now the loop ends. So this is actually very useful for writing code that you want to continue until like a certain condition is met. Okay. Now we're going to get into Python conditions. You can go to this site and learn the basics of this. Once again, very useful. Very useful tools online. That's a lot of this I learned. I went to school for this, but also I learned a lot of it online as well. So Python supports the usual logical conditions for mathematics. So equals is that one value equals another value. If it equals, so basically you test all these statements, and we've looked at this to a degree before. And if the statement is a true, it returns true. If it's false, it returns false. So if A does equal B, it will be true. This will return true. But if they're not, it will return false. If A was not equal to B, it will return true. But if it was equal to B, it would return false. If A was less than B, it'd be true. But if it wasn't, it'd be false. if A was equal to or less than B, it'd be true, but if A was bigger than B, it'd be false. If A was greater than B, true, but smaller than B, false. And if A is greater than or equal to B, true. If A is just smaller than B, false. These can be used in several ways, most common if statements and loops. So basically, an if statement, and we'll get into it actually right now, if statement is written by using the if keyword. So, for example, there A equals 33, B equals 200. All right, so, and the if statement is B is more than A. So this is true based on this data. So since this is true, this if statement then runs. So the block code that is indented below the if statement will run. So let's just run this whole thing. And then since B is larger than A, then the if statement is triggered because this is true. And then it goes to the indentation code below the if statement and then runs that code, which is print B is greater than A. In the example, we use two variables A and B, which are used as part of the statement to test whether B is greater than A. A is 33 and B is 200. We know that B is greater than 30, and so we print the screen B is greater than A. All right, but now let's run this. So now let's change this. So now let's run this switch. So now we're going to say that B is smaller than A, which is a false statement because 33 is smaller than 200. And since this is a false statement, let's actually make this more clear. You can see that it did not print B is greater than A because since this is a false statement, it does not activate the if statement, so you don't actually run this code here. The else keyword catches anything which isn't caught by the preceding condition. So the extension of the if statement is that, so it first starts with if ABC, and then it hits and sees if it checks if it's true. And if it's not true, it continues on to the next piece of code. And usually it's an if-else statement. An if-else statement is A more than B is equal to B. If that is true, it's going to actually activate the if-else statement. And then if all the if and if-else statements above it fail, you put a else statement, which is a catch-all. It doesn't have any condition. It's always treated as true as long as you reach it. It will run it. So let me just run the code. You can see here, it goes to the if statement. B is not bigger than A, so it does not print this. Then it goes to the if-else statement. They are not equal to each other, so it does not print this out. So then it just goes to the else statement, and since it passed these two, it then runs the else statement. So let's actually change this to actually equal 200 so they equal each other, and run this again. And now you can see that it hits the if statement. B is larger than A. Nope, they actually equal each other, so it passes by this, does not run this code. Then it hits this if else statement. They are equal to each other, so it does actually run this code, this indented code but underneath this if else statement, and prints it out. And then since this actually ran the program knows to ignore this else statement and does not print out this. All right. Let's just return that to where it was. If we went over this a little bit here, the if keyword is Python way saying if previous conditions are not true, then try this condition. So once again, if the if statement before isn't true, run this. But the thing is actually, you can essentially, the if else statement, you can have as many as you want as long as you have like an if at begin it before it. You can have as many if else statements after it. Let's run all this. And you can see here, B and AB are equal to each other because they are 33, 33. So it goes through here. This statement is false. Then it reaches if else statement, and this is there. But actually, let's actually change this to make A bigger. See what happens then. And then you can see nothing's actually happened. So it goes through if, and it produces B is not larger than A, so it doesn't run this code. And it hits the if else, and then they are not equal to each other, so it actually doesn't run this. So then it continues, and it just doesn't have anything else to continue to. And that's why you want a else statement to catch like the data actually not being processed, even if your else statement is literally just this didn't work, essentially. Um, so I always have an else statement below all this to make sure that actually you see that something did not work. And this is another example. It was actually its ad to illustrate something. If else, let's do equals, and then are equal. So let's run this code. Let's clear everything out first. So you can see here it runs. It gets the runs the if statement first. B is not larger than A, so it doesn't print out this. It doesn't do this code. If else, B is not larger than A, so it doesn't do this part. And then, oh, this is why I did that. And then let's change this. And then it does the if else is that it equals, and then it does equal, so it does print that out. But then you have, just in case you have an if else statement down here that catches if the data wasn't run. So we went through all this. If B is not larger than A, B is not smaller than A, they are not equal to each other. There's something wrong at that point if this code is actually working correctly, because there are supposed to be two numbers and they would be either larger than each other, smaller than each other, or equal to each other. And if it doesn't, then it would print out data not run, so that indicates to you that something's wrong with something wrong happened. Something that's not supposed to happen happened. The AND keyword is logical operation, and they use to combine conditional statements. So basically, the AND statement is, let me just run this, clear this, clear this, run this, run this, and you can see here that it's both conditions are true. So basically, if statements, you add if statement, and then you have, like, instead of having just one thing to test, you'd actually test two, and both of these have to be true for it to continue. Let me change this really quick and make let's make A just 1, and you run it, and then it doesn't do anything because even though A is smaller than C over here, so this is true. B is not smaller than A, so this is false. So if there's even one false in an AND statement condition, it will register all of it as false. So since this is all now registered as false, it does not run this. All right. So basically, the AND statements, you just put you can have multiple AND statements. You can have AND. You have as many as you want, but as long as there's one false in an AND state, and then like the string of AND statements, they're all false. The opposite is true for the next one. The OR keyword is also option used to combine conditional statements. So, OR is not the opposite of AND, but essentially does work in the other way. If one of the statements in the OR chain is true, the whole thing is treated as true. So, for example, let's run this code. You can see at least one of the conditions is true, because even though A is bigger than B, so that's true, but A is definitely not bigger than C because A is 200 and C is 500, so this is false. But since one of them, and this is true, this whole statement is treated as true. This whole statement right here, the whole OR statement. So that means that it's true. The if statement can run, and then it runs the code indented below it, and that is at least one of the conditions printing. At least one of the conditions is true. The not keyword is a logical operator and is used to reverse the result of a condition statement. So the not keyword essentially reverses. It flips. So if you let me show you for example, it's actually not true. Ooh, I spelled true wrong. Not true. Not true. So you run not true by itself, comes out false. So it's just the opposite. Not false. Not false. Not true. False. Not false. True. So basically, let's go from right to left. So this statement, A is greater than B. So that is false. This statement is false. A is not greater than B. But then you add this not to it. So suddenly this false statement becomes a true statement combined with the not. And thus, you run the code. If A, becomes a true, the if statement does run, and it prints out A is not greater than B. You can add if statements inside if statements. This is called nested if statements. So you can actually nest loops and if statements. A lot of programming is there's some amount of nesting. And you can see here is that the first statement here, if statement, is on the line right here. And then you can see the indent for the code below it. And then you can see that you have another if statement inside the if statement, and you can see it indents again. And essentially you can put like loops and indents within each other. Let's run this. So it goes from x is equal to 41. If x is larger than 10, then go into the if statement. So it does. It prints above 10. And then it hits if x is larger than 20, continue. And then it hits this and prints also above 20, because it is 41, so it's above 20. But then this else statement is not used because this if statement inside its chain was used. if statement cannot be empty, but if you are for some reason have an if statement with content, put a pass statement to avoid getting an error. So you can see here, this is actually this. Get rid of this for a second. Let's run this code. Actually, it doesn't do anything. I think PyCharm is knows not to deal with it. So once again, the pass statement can be used with an if statements, and it just passes on if like there's nothing in here, or you have a if or you want like you have an else statement and you just wanted to continue without saying anything, you can just tell it to pass. All right, that is everything. Um, there's no real homework for this class. I just want everybody to go over this code and just code anything. You have enough information now to actually code your own things. We're going to get into next class into BioPython, but right now you have like a basis to actually write your own basic code. So you can go ahead with that. And that is the assignment, essentially just play with the code you already learned. All right. Thank you for watching and listening, and I will see you for the last Python class next session. Thank you. Bye.